You to today's webinar titled Getting Started with Google Cloud Platform. I'm going to hand things over to our featured presenter today. He is a senior consultant at Stone Door Group, Mr. Tim Gerlich. Tim, you now have the floor.
Thank you, Kelly, and good morning, everyone. This morning's webinar is getting started with GCP, Google Cloud Platform. And Google Cloud Platform is fairly complex. There's a lot of different pieces to it, a lot of different, I don't want to call it products, they're all part of the one product, but there's a lot of different pieces to it inside. And so my plan for today is to just kind of go through and introduce GCP generally, and then we'll, in the middle 3 sections there, we'll talk about the primary areas of GCP, infrastructure, the infrastructure solutions, additional GCP solutions that you layer on top of the infrastructure pieces that you'll typically use. And then we'll talk about some of the more advanced platform as a service or serverless solutions that Google also has. And then finally, we'll wrap up step 5 there with what are the next steps? What do you do after you've kind of gotten a handle on GCP? So with that, let's jump into it and look at introducing Google Cloud Platform. GCP is Google's public cloud offering. It's similar to AWS, Azure, and a lot of other vendors have sort of their own versions of that. There's DigitalOcean, and VMware I know is doing it for a while. I don't know if they're still doing it. But these are kind of the big 3, GCP or Google, Amazon Web Services, of course, and then Microsoft. And so for Google to stand out, they have kind of this key differentiator, which is that the stuff that you are using when you sign up for and start utilizing GCP services is the same stuff, that's the technical term, by the way, the same stuff that Google uses internally and Google uses for everything that you do whenever you go to google.com. That all of that big data, the search functions, maps, all of the different services, G Suite, all of those services are running on the exact same platform. And so it's massive, it's cutting edge, and it's time tested. Google has been using it for a long time. And it's like the typical sort of thing, Google developed all of these things in-house for their own purposes and then decided, hey, these are great services. These are things that the public could use. And so they've made it available to you guys. Now, GCP is not a small player. They have some huge enterprises, companies like Coke, Coca-Cola, Niantic, which created Pokemon Go. And there's kind of an interesting story around that where, you know, Pokemon Go, they knew it would be a kind of a fun thing, but they never really expected the level of demand that appeared when they released it. And it was just huge. They scaled to, and GCP scaled to 50 times their expected traffic in the days after the launch. And it was seamless. It just kept working, and none of the players, none of the users even realized what was happening. If you go out and Google it, there's a nice blog entry about that experience from somebody at Niantic who walks through kind of the launch and what happened in the immediate days after that. All right, so that's GCP. That's kind of the big picture. But let's jump into some of the services. And the bulk of what we're going to talk about over the next little bit, the next half hour or so, is the different services that are available to you within GCP. And those services range from, there's all the AAS things, right? So it ranges from infrastructure as a service to fully managed serverless software as a service, where you're just using some functionality, but you don't have to maintain the infrastructure that supports that. You don't have to maintain any operating systems. You don't have to worry about how many virtual machines you're running to support that. It just works for you and scales on demand as you need it. So we're going to kind of move through that path or that scale. The first step for most people when they move to cloud or public cloud technology is typically infrastructure as a service. It's the easiest thing to transition to. taught for VMware for a long time, taught classes for VMware for a long time, and you know, in the early days of VMware, we used to explain what virtualization was, but that's not needed anymore, right? We don't need to do that anymore. Everybody knows what virtualization is now. Everybody has virtual machines, and you probably have data centers where you're running virtual machines in-house, on-prem. And as we know, I mean, virtual machines are great. And don't get me wrong, the cloud and cloud technology does not get rid of the need for virtualization, not even a little bit. It's just kind of now foundational, and we're going to layer on top of a lot of that the additional functionality. So the first step to the cloud is typically infrastructure, basically taking your existing virtual machine system, virtual machine based system where your apps are running, and instead of running all of those in-house, you run some of them or even all of them in the cloud. It's easy for your IT folks to understand. It's fairly simple to transition because it's very similar. It's just a difference of where are the virtual machines. GCP's infrastructure solutions include those listed there. Google Compute Engine, which essentially is virtual machines. Software-defined networking, which provides a virtualized network infrastructure that makes your life a lot easier from a networking perspective. We'll touch on that. And then storage solutions to support all of this. So let's take a look at those. Oops, excuse me for the mouse. Google Compute Engine, it sort of forms the basis for what most people start off doing. Hosted virtual machines are often the first thing that you move to the cloud. You've got virtual machines at home, or at home at your data center on-prem, and you're going to host them instead with a cloud provider like Google. And like I said, it's a pretty easy transition to go from on-premise infrastructure to a hosted infrastructure. There's a lot of tooling that Google has to make that seamless. You can set up a VPN between them. There's other kinds of network connections that you can do between your on-prem data center and Google's cloud that make it look like it's all just one big seamless network and everything's together and so on. But once you do that, once you move your virtual machines to the cloud, then that opens up just a wealth of other tools and features like firewalling based on tags. You can tag a virtual machine or we call them instances. You can tag some instances and say compute instances, and with a tag that says this is payroll. And then you can build firewall rules using that tag without even caring what network or subnet it's on, what its IP address is, or anything, right? So there's all kinds of things you can do once you start doing that. When you move to Compute Engine, you can use pre-baked virtual machine images that Google provides for you, Linux and Windows images, or you can import your own that you've already built and from different environments, from vSphere, Hyper-V, whatever. You have complete control over the operating system, of course, when you're using virtual machines. You log in and you are responsible for maintaining that OS and keeping your software up to date and all the other things that are needed. And it's pay as you go, and I'm not going to spend time today talking about the cost structure. I will just simply point out two things. Number one is Google obviously is very competitive, especially with Amazon. There's actually kind of a bit of a price war going on, and that's to your benefit as the consumer of these services. But the other thing too is that part of that first point is that Google is very transparent about pricing. For every product that we look at today, every solution that we look at today, there's a pricing page. Like on the introductory page on their website, there's a pricing link that takes you and just says, hey, here's the pricing. And there's even a price estimator, so you can estimate. When you create a compute engine instance, then it will actually, there's a price estimator. They'll say this will cost you $25 a year, $54 a year. So nobody can really memorize all the prices. I don't have all of the per second or whatever prices memorized. So that's why I try to avoid talking about it in classes. It's always changing as the competitive landscape changes. But the one other thing that I will point out is the preemptible instances, which are virtual machines that Google can take away from you and shut down at a moment's notice. And actually, it's a 30-second notice. So if they need the infrastructure, they need the cycles for something else, somebody who's paying for a full not preemptible instance, and they can take it away from you. And typically, they'll give you up to 30 seconds notice to do that. But the neat thing about that is it can save you an immense amount of money, which is really cool because it's really, really cheap. And this is just an example of how easy it is in the Google Cloud Console to create a compute instance. Give it a name, specify the region. The different regions in the US, Europe, Asia, and so on have different pricing. Slightly, it's typically fairly close, but different pricing. How many CPUs and so on, and there's pre-built versions, like that one with one virtual CPU and a 3.75 gigabyte memory, and then you can customize that. And there's other things you can do. I'll use my mouse to kind of show you. You can specify a different boot disk. This is the default when you just say create a new one, Debian GNU Linux. But you can change that, and service account, what service account to use for it, to do things on its behalf. And then in particular down here, I couldn't expand this on the screenshot because it would take up too much space, but you can control things like how the instance is managed, the security of it, tags and that sort of thing, what disks it has, networking, and even sole tenancy. And there's the link, right? You will be billed for this instance, and then there's a link right there for the compute engine pricing, which is pretty cool. Oops. Now, the second piece of infrastructure is software-defined networking, and I could spend, and I do spend in classes, a few hours talking about how networking works in GCP. So in here, I'm just going to kind of give you the high-level 30,000-foot view. It's all built on and using Google's global private high-speed fiber network, and they have their own cables going under the oceans, for example. GCP sits on top of all of that physical networking, but it absolves you of the need to manage or even think about it. Essentially, you go in and just say, I need a network. In fact, you don't even need to do that because, for example, when you create a GC compute engine, a GCE instance, then it'll create and use the default network for you. And it will give you subnets in every region that Google supports. So you don't even need to think about it if you want to use the default networks, but you can also go in and create your own networks and then start working on firewalls and stuff like that, what kind of firewall rules you want to have. And those are all also logical software-defined firewalls. They're not physical boxes sitting anywhere. So this totally changes how you think about networking, especially if you're like the architect or a developer who's writing code and thinking about, okay, where are the different microservices that make up my application? Where are they going to live? How am I going to reach them? What do I need to do there? You don't need to think nearly as hard about any of that stuff. So it's very, very nice and very, very seamless for you. It takes a little getting used to if you're used to doing regular networking, but all the firewall rules, routing, and so on, all that stuff is managed for you, and there's very little that you need to think about. Now, in terms of network objects, this is software-defined networking. So network objects are global in scope. You create a network, and it just lives in the entire world. There are no IP addresses in a Google network object. IP addresses are done through what are called subnets. So you create, see how it says there, VPC, Virtual Private Cloud Networks? You create a VPC network, and then there's different types. You can use default and let it give you subnets in each region, or you can create your own. It's totally up to you. But what this means is that the network is what you work with. And you can see, for example, there, this default network where every region gets its own subnet object, and there are different 10.128, 10.132, and so on. And the cool thing about this is you can have, like the example there, a virtual machine in Hong Kong and another one in Belgium. They have different IP addresses, different subnet numbers, but they're on the same network. And so that just makes communication between them seamless. makes firewalling issues between them seamless. So it does take a little getting used to, but it's a pretty cool thing, pretty cool feature of it. And then the last major infrastructure piece that we'll look at is storage. So there are a lot of different storage options, and there are persistent disks, block storage for your virtual machines, hard drives or flash-based storage that persist. And that's fairly typical to use that, especially when you're using GCE and compute instances. We also have what's called cloud storage, which is Google Cloud Storage. It's an object-based store for just arbitrary data blobs. I love how that's leaked into our vernacular, right? Our vernacular, blobs, data blobs. So you create a bucket and you put stuff in it, and it can be any kinds of stuff. And there's different classes for different needs, like how long you like offline, nearline, and so on. There's different classes, and you pay more for more immediately available. The one cool thing about that, though, is that even the cold line storage is very, very quick to retrieve. It's just that it's almost as fast as regular, like persistent storage. Not quite, but almost. And the main difference is that we actually do store it somewhere different, and we don't expect you to access it very frequently. And so there's a higher charge for going back and getting it. It's kind of like for doing backups or storing things that you're not going to look at for another year or so. But there's all these different classes, and you choose what makes sense for your data needs. And then we also have, and when we talk about storage, there are different database solutions. And again, in the core infrastructure class, we spent a lot of time talking about each one of these. We have NoSQL or NoSQL solutions called Cloud Data Store and Cloud Bigtable. And we have, and these are some of the things that Cloud Bigtable is used, for example, in Google's infrastructure for things like maps and stuff like that. And then we also have, if you have the need for it, relational database solutions. There's Cloud SQL, which has MySQL or Postgres as your options. You can just create your own database, but it's a managed service. So, excuse me. So you don't have to think about installing MySQL, for example. It's just you say you want one, and it creates it for you. And then we also have Cloud Spanner, which basically takes this relational database concept but scales it across regions and across the world, basically, and it scales up to thousands of servers. All right, so those are kind of some of the core infrastructure pieces that we have. The next thing we're going to look at are additional GCP solutions to augment your core infrastructure. We like to think of these additional solutions as force multipliers. In other words, you can do a lot more with fewer resources, and management really likes this with fewer admins. Now, I don't know the audience completely, how many of you are managers and how many of you are, individual contributors or whatever. You might think, well, I don't want fewer admins, that's my job. But on the other hand, becoming proficient in this in GCP makes you really valuable, because now you can be the person that makes this possible for your organization. So we can break these kind of force multipliers or these additional solutions down into two categories. There are some scaling and high availability tools, and then there are some tools to help you automate your infrastructure. And we'll look at both of these over the next few slides. Scaling and high availability. When we talk about scaling, the old school way of doing things, especially for you guys who are developers, right? The old school way of doing things is, as your application grew and needed to do more functions, your legacy applications, and as they needed to do more functions, or as the demand on the applications grew, typically what you would do is you would scale vertically. You would buy bigger and more hardware, more CPUs, more memory, more storage, create bigger virtual machines to handle these increased loads, because you have this application that's growing and growing and growing, and it's a legacy app that does everything in the one app. You couldn't really split it up onto different systems. And then the other way to scale is to scale horizontally, where you have essentially more copies of your app, and typically in more locations, spread it out around your demand area, whether that's your country or the world or whatever the case might be. And to be quite frank, scaling horizontally is the future. That's the way we're all going. I also teach Docker classes, for example, and we're just like, we can't stop doing Docker classes because Docker and containers allows you to, like, there's so much demand for it because all these huge organizations are changing their development model to containerized applications built on a collection of microservices that running in containers that can scale horizontally and that can all work together. Well, this plays right into GCP because one of the things that GCP gives you is auto-scaling capabilities, the ability to automatically scale up or down based on the demand for your application. And of course, management loves that aspect as well because not only is it performant and gives you what you need in terms of satisfying your customer's demand or your user's demand, but it's also cost effective because you're only paying for when there's demand, as opposed to an on-prem data center where you buy all this hardware and whether it's being used or not, you are paying for it, right? You're paying for the hardware over time, you're paying for the electricity, you're paying for the management. The other thing about this design, this development design, is that you have a single ingress point to your app. Your consumers, whoever's using your applications, go just to one spot and one ingress point, one URL or one IP address, and they get access to the application without having to worry about what's happening behind. So within this scaling and high availability area, we have three main solutions or features: instance groups, auto scaling, and load balancers. Instance groups are basically a collection of virtual machines, or compute instances as we call them, where we bundle them together for load balancing and manageability purposes. So essentially, you just use a template. I'll give you a little sample there. Use a template to automatically create the instances, and then you can do what's called demand-based auto scaling, and you can specify limits. For example, see their maximum number of instances is 10, minimum is 1, so we'll scale up to 10. And that way you can put a cap, for example, on your cost if that's an issue for you, and so on. And there's also instance groups also address reliability issues. If one goes down, one of your instances goes down, auto healing will bring up a new instance to take its place. With auto scaling, this is just a little more about that in terms of instance groups. You can auto scale instances based on different metrics. It's almost unlimited. When you get into it and start looking at it, you'll see there's a simple menu setting. You turn auto scaling on. That's the first little example there. And then it scales up or down, and it will scale down also. It will delete virtual machines when they're no longer needed based on the demand metrics that you've specified. And like I said, this way you don't need to pay for idle virtual machines. Load balancers serve as a front-facing entry point to your application. So this is that single ingress point that I was talking about. And the load balancer, again, it's a software function. It's a logical load balancer. You go in there and create it, and we have different types, which we don't really have time to talk about right now. There's, I showed you at the bottom, right? When you create one, it asks you what type you want: an HTTP load balancer, a TCP load balancer, or a UDP load balancer. And they have different, features and use cases. So you'll examine those, explore those, and then decide what makes the most sense for your application. But the load balancers are logical. They can be global, and meaning that you have one URL, for example, for your consumers, www.newhorizons.com, and it goes to that URL. The users go to that URL, and then if you're in Asia, it might take you to instances that serve that URL in a data center, a Google data center in Asia, and in the US, New York or Los Angeles or wherever it might be. The load balancer will detect unhealthy or down instances and then automatically redirect the incoming traffic. And for you folks who are architecting these designs, you no longer have to think about any of that. It's as simple as create this load balancer, point it at an instance group, and you're off and running. I like to make it sound simple. There's a lot to learn about this stuff. We're just doing the high level stuff, but it's pretty cool. All right, automated infrastructure solutions. So this is the second half. Remember we said high availability and scalability. Now automated infrastructure. GCP has a number of different automation tools, including RESTful APIs that you can use to write your own code or scripts to do things within GCP. We have something called Deployment Manager and Cloud Marketplace. And those last two are actually, we present them as different things, but they're kind of related. So we'll see that in just a minute. Every GCP product has a RESTful API that is exposed for you to use. And in fact, even our Google Cloud Console, I'm doing all these screenshots from, except for this one. This is actually the API Explorer page. But all of the pages that the front end pages that you see in the Google Cloud Console are actually just using the same API that we've exposed to you. So anything that you can do in the console, you can do yourself in any way that you want, as long as you can write code that will take advantage of the RESTful API. And you can use that to automate provisioning of your services and your applications in ways that make the most sense for you. And now, it's always that trade-off, right? Like, you probably want to use the baked-in functionality as much as possible, because every time you go out and write your own code to do something with your infrastructure, you have to maintain that and keep it going forward and so on. But it is available to you for those organizations that require it. And then, as I was saying, this is the APIs Explorer, which there's a link to it from the console. You can click on it, it'll pop up on this new web page, and you can go in there and look at every single different API that's out there, and you can explore it, you can test it out, you can practice with it, and so on. Okay. Now, Deployment Manager is this next piece of this. Deployment Manager is a tool or solution within GCP that lets you define essentially your entire infrastructure that's needed, all the infrastructure that's needed by your application in template files. And because they're all in files, you can implement them or store them in version control systems. You can repeatedly deploy exact clones of your infrastructure pieces, which is nice. And somebody somewhere coined a term for this called infrastructure as code. And you can kind of see it here where we're using Deployment Manager. This is actually from when you take classes, when you take classes from us then, or from Google, then we use something called Quick Labs, which is Google's lab-based environment. And deploying those labs is all done through Deployment Manager on the back end, right? So it's actually really cool. And what you'll see is on the next slide, oops, sorry, did I go one too far forward? Yes, Cloud Marketplace. So we have something called Cloud Marketplace, which builds on top of Deployment Manager. And essentially what this does is, like I said, we are using Deployment Manager internally. You can create your own templates for your own infrastructure and deploy your infrastructure automatically using those templates. But you can also go out to the Cloud Marketplace, which is, think of it kind of like an app store, and go out to Cloud Marketplace, and or whether you're providing consumer-facing stuff or whether you want to get some of these solutions, there are hundreds of different, you can see there, right? This is filtered by, this is actually the main page. There's 586 different virtual machines that have different applications already pre-installed into them. And there's a Deployment Manager template that you can just download and use. And so it's kind of cool, like right over here, right? You can just click to deploy. Say, yep, I'm going to deploy this WordPress site, and you click that and you're off and running. It'll deploy all the things that are needed to run your WordPress site. And then, of course, once you do that, you can fine tune it or customize it or do whatever you need to do to it. So there's this huge third-party marketplace that you can take advantage of, and you can also use, and it's just built on top of Deployment Manager, or you can use Deployment Manager internally for your own environment as well. Now let's move into section 4, Platform as a Service Solutions. So all this stuff that we've talked about is mostly built on kind of infrastructure pieces. We talked about Google Compute Engine and all the infrastructure like storage and networking that go along with running that and moving your infrastructure from on-prem to the cloud. But we also have within GCP a number of different platform as a service solutions. And these solutions allow you essentially to make use of software or components without having to maintain or even think about the infrastructure that's required to build that or to run that. So we have two types of PaaS, platform as a service solutions. We have what are called serverless applications, including Google App Engine and Google Cloud Functions. And then we have container-based solutions that are Google App Engine Flex. So it's App Engine, but we have two versions of App Engine. And then there's also Google Kubernetes Engine, or GKE. This, if you've been around for a while, you might have seen this referred to in the past as Google Container Engine. And they changed the name of it because it's really more focused on Kubernetes itself, even though it's using Docker under the covers. But also, GCE is Google Compute Engine, and so I think that was confusing for some people. So they wanted to clarify which one you're talking about, GCE or GKE. Let's talk about Google App Engine. App Engine deploys your app and scales to essentially as whatever you need, near infinity if needed. Now, of course, we can't scale actually to infinity, but we can get pretty far up there. So App Engine is ideal for web applications or mobile app services where you need to scale quickly and potentially very, very high, like to a large number of applications. We also support rolling updates where you can roll out a new version of your application and then update over to it, and even go roll back if there were problems and stuff like that. So these kinds of things are ideal for your CI/CD, your continuous integration, continuous deployment pipelines, because it really hooks right into all of that infrastructure that you are already using. The thing about Google App Engine, this is down here when you're deploying Google App Engine, you specify standard or flex. And standard is limited to the number of languages, Python, Go, and so on. There's about 6 or 7 different languages. You could just go to the App Engine page to see that are supported. And it's standard, it's fairly fixed, and you can just take your Python code and deploy it in App Engine and you're off and running. We also have cloud functions. So cloud functions, these are again serverless functions. Cloud functions are kind of this neat concept where you can have little pieces of code. So there's some JavaScript code here. You see this index.js, Node.js code. You put your code in and you can have your package.json and upload that as well. And essentially, you can upload it, you can write it, paste it in, whatever. But you create these little cloud functions and you give it a name and how much memory it should be allocated and what kind of trigger. The HTTP is typical. And then it will give you the URL to hit it. And then from within your applications, you hit that URL to launch or make use of that cloud function. And you just pay for when that function runs, and that's it. You don't have to pay for it to sit around some virtual machine, to sit around idle, waiting for a customer to come in and exercise that particular function on your web page. And so it's very cost effective. It scales very quickly and very fast because essentially the Cloud function launches instantaneously when you hit it. And so it's, again, there's an API for it. And so it's very, very cost effective, very, very efficient, and very performant. So I'm really a big fan of, and I'm not a developer, but I recognize I teach a lot of sort of higher level CI/CD type of classes and helping people to integrate, helping developers integrate Docker, for example, and GCP into their environments. And it's a big hit because of how useful it can be. And the other thing too is, excuse me for going forward, the other thing too is by creating Cloud functions, then you can reuse them, right? You can reuse them in other applications. So you have this little function that does something. This one's kind of silly. It's a hello world one, but you can have some, and you probably don't have a lot of applications that require somebody to print out hello world to you, but you might have little functions that you find you're implementing through libraries in multiple places throughout your environment. You can implement them instead as Cloud functions, scale them up as needed. Now, App Engine Flex, Google App Engine Flex. This is the easiest way to deploy Docker containers into your environment. Because you're deploying containers, you can essentially do whatever you want in there, and you can use different languages beyond what App Engine standard supports. Containers that you deploy with App Engine Flex can deploy and scale automatically. So again, as they're needed. You do have to provide the Docker file that describes your application and also a YAML file that essentially describes the service that you're deploying. You deploy App Engine Flex using what's called the Cloud SDK, the Software Developer Kit. All that really means is, I don't know how many of you have ever logged in to GCP, but you know how, if you have, there's a little button you can press to open up what's called the Google Cloud Shell. It's a small little Linux virtual machine that has the SDK, the Cloud SDK built in, which basically gives you all the command line tools for interacting with GCP. You can do things like look at your storage buckets, create virtual machines, but pretty much everything you can do in the console, the browser-based console, you can do that in the through the Google Cloud Shell. So the Cloud Shell is just a convenient way for you to access the Cloud SDK, but you can also download the SDK to your laptop or your desktop machine at your office and install it there into like a Linux virtual machine, and then you can work locally and have it operate against your GCP environment. So that's how you deploy App Engine Flex. Now, that's pretty nice, the fact that you can do that. You can basically create your own containers and deploy them directly. I should say also, we don't really talk about it in here, but you can also, if you really wanted to, you could deploy Docker and either Kubernetes or Docker Swarm orchestrator into your own GCE environment. I mean, you certainly are welcome to go do that. And then you manage the nodes, the Docker nodes. You manage Kubernetes or Swarm, whichever one you're using. You can use UCP, the Universal Control Plane, and all that stuff. You can do all that by yourself, but that somewhat defeats the purpose of having all of this scalable functionality at your fingertips. So you can do that. You can deploy your own container infrastructure. You can use App Engine Flex, or you can use Google Kubernetes Engine, or GKE. Kubernetes was actually written at and developed at Google. It came from Google. And back in 2014, Google developed Kubernetes over the years for use internally, for all their massive infrastructure that they're running internally. And in 2014, they made the decision to open source Kubernetes. They released it to the Cloud Native Compute Foundation, CNCF. And Kubernetes is now open source. So anybody who wants to can go out there and download Kubernetes and use it and deploy it. As I said, Docker, actually in their enterprise edition, they include Kubernetes prepackaged up and ready for you to go, so you can choose to use that. but again, in Google and GCP, of course, since Google has so much expertise with Kubernetes and they wrote the original versions of it, they make it available to you as a managed service. So you can deploy, scale, and manage your containers using GKE. Typically, it means that you go in and you say, well, I want X number of nodes. And I have to apologize. I'm just noticing that I grabbed the wrong screenshot. This is the same screenshot from the previous page, and I did not catch that in my pass-through, so I apologize for that. But deploying Kubernetes is pretty straightforward. You go in there and you just say, I want, a cluster of Kubernetes, a Kubernetes cluster of X amount of nodes, and it goes off and does it all for you. You don't have to install it. It'll keep it up to date and so on. So you don't have to manage your nodes, or at least manage it more than saying I want them and deploying them. So with GKE, you just specify the number of nodes and you're ready to deploy your containers, as opposed to running it yourself. Now, here's probably the slide I meant to put, the screenshot I meant to put on the previous page. To deploy a container or deploy your apps in containers once your Kubernetes cluster is deployed. So when you deploy the cluster, you basically just go in there and say, give me a Kubernetes cluster, and it goes off and does it for you. There's no cluster management required. And then you just say, I want to add a new container image, right? So, or edit an existing one. So I can say new container image, I'm going to run nginx latest. So for those of you who do Docker, you know that that's a Docker image that we're referencing there. But it could be your own. You could put in, your own URL to Docker Hub or to your own registry, wherever you're storing your corporate images. You can add environment variables, say what command to run when the container launches, and so on. And you can really customize it a lot. All right, the next step. So that's it for kind of hitting the key features. And you probably noticed there are, like, we didn't talk a lot about big table and big query and a lot of the big data stuff, and we didn't go into detail on the database stuff. There's a lot to GCP. It's definitely one of the more challenging things to wrap your heads around, any cloud provider, whether it's AWS, GCP, whatever. So the next steps, if you're just starting out with GCP and you've decided, yes, I really want to learn this, I really want to go in this direction. My advice to you folks is, first, go out there and just set up an account and start exploring. There's a couple of different ways. You first go to cloud.google.com, log in with your Google address or create a new one or whatever you're going to do there. Google has a free tier of different services, and I gave you the URL there, that includes a $300 credit to get started with any GCP product, so you can just go in there and start playing and without worrying about having to pay actual dollars. And then there's also this free tier that's always free, that includes certain usage limits on participating products. So it's not quite everything, but there's a bunch of, like, compute engine and stuff like that. So it's a good way to get your hands or get your feet wet, right? To get in there and just start playing with it and exploring with it. There is no substitution for hands-on. I highly encourage you all to get out there and get some hands-on experience. And then once you're starting to really get doing this stuff and you've decided that this is where you want to focus your energies for a while, then I would highly recommend that you consider getting certified. And Google has a number of different certifications. There's even like a G Suite admin one, but that's not Google Cloud, so that's why I didn't include it here. There's an associate cloud engineer certification, a professional cloud architect. That's kind of the bread and butter certification. So people typically start out with that, or those two, get the associate first and then the professional. And then if you're a developer, they have the professional cloud developer cert. And if you're a big data person, there's a professional data engineer certification. Google is coming out with 2 new certifications: Professional Cloud Network Engineer, which is in beta currently, and Professional Cloud Security Engineer, which is also in beta. And as a Google certified instructor or authorized Google trainer, I think is what they call it. They've been offering us, they just last week said, hey, anybody want to take the beta exams because for half off or whatever, because they need to sort of test them out and see how people respond to them and so on. So we're going through that process right now with those 2 certifications, and I will expect those to be out before too long. And then, oops, excuse me, it's almost impossible really to go this route and become Google certified, especially that architect one, the professional cloud architect, without doing some training. You can spend your time doing hands-on, but it will probably take you a number of years, and to get to the level just with hands-on, practical experience to be able to pass the exam. And the primary reason for that is the exam covers all the products, all the solutions within the infrastructure side of things, the architect side of things. And you might not be using every single solution that GCP offers. And so the training is a great way to kind of round out, even if you're experienced already, it's a great way to round out your knowledge. And if you're new to all this stuff, it's a great way to bootstrap you and get you going. So on the slides, this slide and the next slide, I'm going to show you kind of just the recommended courses for, on the left, Associate Cloud Engineer. If that's where you're starting out, Google Cloud Platform Fundamentals, Core Infrastructure, and Architecting with GCP Infrastructure. And on the right, it's those same 2, Google Cloud, the Fundamentals class, the Architecting class. Then we also have a Design and Process class, and there's a Preparing for the Professional Cloud Architect exam. And that last one is relatively new. It's been out for a few months now, but that's a lifesaver when you have to go take the exam, especially when you're taking it for the very first time. So those are our recommended courses to go through. And these are typically 2 or 3 day classes. Some of the fundamentals one is a 1-day class. You can usually bundle them together and get 4 or 5 days worth of training, get it all out of the way right in 1 week. And this is not moving forward. Okay, so the other 2 sort of course tracks that we have, developing for the professional cloud developer, we again recommend developing apps with Google Cloud Platform, and then the fundamentals core infrastructure. You don't need to know as much about all of the different, you're not doing architecture, you're doing development. So you don't need to know all the different sort of infrastructure and solutions out there. And then the on the right is the recommended courses for the professional data engineer. There's a From Data to Insights with Google Cloud Platform, Data Engineering on GCP, and then also again, there's a Fundamentals class on Big Data and Machine Learning. There are other classes out there as well. We've got a security class coming out and stuff like that. So you can go to newhorizons.com down there at the bottom. There's our 800 number also, or 888 number, to get more information. New Horizons is a Google GCP authorized training partner that offers training and certification for you and your employees to make the most of all of these GCP technologies. Knowledgeable instructors, I like to think of myself as being somewhat knowledgeable, so I'm one of them, with the technical skills and the best practices to get you up to speed quickly. And we have fundamental to advanced level training in all the different sort of formats, live, virtual, and on-demand options. And just FYI, some upcoming classes that we've got on the schedule. This will be in your slide deck when you get this or when you look at the recording. And you can also go again, of course, to newhorizons.com and see more information. All right, so I want to thank you all for coming. Hold tight. I think Kelly is going to get a couple of questions and wrap things up. And once again, thank you for your time.
Thank you so much, Tim. And thanks again, everyone, for joining us today. If you guys have any questions for Tim, please feel free to type those in now, and we will address those over audio. Just to reiterate what Tim had mentioned, please reach out to your local New Horizons Center for further information on all of our course offerings. If you are not familiar with who your local New Horizons Center is or your local New Horizons rep, you can log on to newhorizons.com and do a zip code search to find the center nearest you. All right, Tim, it looks like we do have a couple questions coming through. So the first one is, how can a user maintain infrastructure as a services environment with up-to-date security patches without compromising other users' environments?
Yeah, so the infrastructure, if you're talking about compute engine, then we have built-in ways of keeping your OS up to date. So you can update your OS and apply patches and those sorts of things. Those compute engines, those instances are yours. Like you'll never affect anybody else. It's like any kind of virtualized environment. You're isolated, you're in your own network. There's no way in your own subnets. There's no way for you to affect anybody else. And so there is tooling around keeping your operating systems up to date, but at the same time, GCE Compute Engine, it's infrastructure. We're providing the infrastructure, but you're still responsible for what's happening within those instances.
All right, and we've received a couple questions on people requesting the recording, so wanted to let everyone know that that will be available to you after today's session. You will receive the recording link as well as a PDF of this PowerPoint presentation. And on that note, I also wanted to remind everyone, if you look in the handout section in your GoToWebinar control panel, you'll see that there's a handout there as well with more information on GCP. So let's see, we have a couple more questions. What are the scenarios when Cloud Machine could be idle and we cannot be charged? Please provide an example.
Do you mean, are you talking about compute instances? I'm going to assume you're talking about compute, like when you say Cloud Machine, you mean a compute instance.
Yes, compute instance.
So when it's idle and not be charged? As long as your compute instance is running, you are being charged for it. And so though, if you don't want to be charged, if you think that the application is not going to be used 100% of the time, whatever's running in that, then we recommend using preemptible instances because it's so much cheaper and they can go away, and obviously your application needs to be robust and expecting that, but then you can just fire up new ones to replace them as needed. But if the virtual machine is there, then you do get charged for it. It's not a lot. I mean, virtual machines are, depending on the size of it, how much they cost, they can be anywhere from $25 a year to thousands of dollars a year.
All right, so that will go ahead and wrap up today's session. So again, thank you everyone so much for joining us today, and we hope you'll reach out to your local New Horizons rep for further training. And thanks again so much, Tim, for joining us. We really appreciate
Not at all, I enjoyed it, thank you.
All right, thank you so much, everyone. You may now log off. That will conclude today's session. Have a great day.